In this study, we examine sources and patterns of gender bias in research participant populations. This research was conducted at the University of British Columbia. Gender bias in data can have serious consequences for people with underrepresented gender identities. For example, previous research shows women are approximately 50% more likely to sustain injury in the event of a car accident, which is attributed to a lack of consideration of women's data in safety system design. Leaving non-binary identities out of design and training data for computer vision systems leads to creating gender recognition systems which misgender people. In HCI, study participants are the primary source of research data. Gender bias in these participants can lead to theories, systems, and design guidelines that marginalize or harm underrepresented individuals. Previous surveys of HCI research participants have shown a gender disparity in the HCI participant samples. As these studies focused on evaluation methods and sample sizes rather than gender, further data is needed for a gender-specific, data-driven analysis to verify the extent of these patterns of bias. We tackle these issues by exploring the following questions. How are women and non-binary individuals represented or underrepresented as participants in HCI research? What are the variables that are associated with the gender demographics of HCI research participants? How can we systematically collect gender data from published research for a data-driven analysis? We conducted this study in 2 phases, interviewing 13 researchers to identify variables connected to gender bias in research participants, then collecting participant data from published HCI research for a quantitative analysis to identify trends of gender bias across all the years of CHI. From our interviews, we identified 3 key variables: participant recruitment methods, the research area of the study, and the year the study was published. We then created a data schema to codify participant gender and related variables and used it to structure data collected from 1,142 randomly selected papers from CHI 1981 to CHI 2020. From our data, we identified several important patterns. While we are starting to see some reporting of gender beyond men and women, non-binary participants are practically invisible. Looking closer, it seems likely that non-binary identities are not being included in demographic surveys. Our next few findings focus on the comparative representation of men and women. To analyze this comparison, we developed a ratio metric called distance from even representation of men and women, DER for short. A DER of 0 means equal numbers of men and women participated in the research. -1 means there were men participating, but no women, and 1 means there were women, but no men. When examining the comparative representation of men and women, we find that the underrepresentation of women is persistent. The average DER of -0.15 that the median hovers around is equivalent to 10 men for every 7 women. This is the same ratio of men to women that previous literature found in 2014. When looking at effects of participant recruitment, we find that the impact of recruiting sources on participant demographics can change over time. For example, Amazon's Mechanical Turk as a recruiting source appears to be becoming more biased in favor of men. Finally, we found that research topics that have a more even representation of men and women tended to be about social interaction, whereas topics that are more prone to a bias in favor of men tended to be about physical interaction. This analysis has identified several weak spots in participant gender practices in HCI research. Our data shows that recruiting practices can introduce gender bias into participant populations, and certain research areas are more prone to bias than others. We therefore recommend these research areas to re-evaluate their recruiting methods. Comprehensive data is necessary for being able to conduct a gender-inclusive analysis of representation, and the invisibility of non-binary participants in our data suggests that non-binary identities are not being included in data collection. To combat this issue, we recommend researchers to follow current guidelines to collect gender demographics in a way that is compatible with complex gender. As a final note, we would like to stress the iterative nature of this work. The co-authors are interested in carrying it forwards, and we welcome suggestions for future directions. Our dataset has been made publicly available, and we encourage further analysis and discussion.